Hello everyone and welcome to Working with Mrs. Dickey. Today we're going to be talking about patterns in division. But before we get into division, I thought I'd just remind you of some cool patterns that we can see in multiplication. So for example, the 5 times table, which people know really well, goes 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and if you look at the ones column, it alternates between zeros and fives through the whole patterns. Another cool pattern is a 9 times table. If you write, you can actually write out the entire 9 times table from 0 to 10, like so. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in reverse, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's your 9 times table from 1 through 10. But we're not worrying about multiplication today. We're looking at division. So these are the rules that are in the math work for you to look at. And these are the divisibility rules. It means that you can divide this whole number by this factor and you will not end up with any remainders. Any number is divisible by any number, but that's when you get into remainders or decimals. So a whole number is divisible by 2 if the number is even. So an example of that is 2,486 is divisible by 2 because you can half all of these. Half of 2 is 1, half of 4 is 2, half of 8 is 4, half of 6 is 3. So we know that that number is divisible by 2. Number 3, or a whole number is divisible by 3. The sum of the digits is divisible by 3. So if we look at 687, is that divisible by 3? What they mean is you do 6 plus 8 plus 7, which gives you 21. Well, 21 is divisible by 3, because if you know your factors, that is 7. So you can actually do 687 divided by 3. Number 4, the last two numbers are divisible by 4. So if we look at 3,572 to see if that is divisible by 4, what we need to look at are these two numbers here. 72, which is divisible by 4. So 72 divided by 4 is actually 18. For 5, the last digit, as I just showed you in the multiplication pattern, has to be a 5 or a 0. So this number, 7,405, is divisible by 5 because this last digit is a 5. And the answer is actually 1,469. Numbers for 6, the number is divisible if it's divisible by 2 or by 3. So for example, if we look at 90, you can divide 90 by 2, gives you 45, or you could divide it by 3, it gives you 30, and actually 90 divided by 6 gives you 15. A number is divisible by 8 if the last 3 digits are divisible by 8. So for example, you could look at 4,920 and see if the last 3 digits here are divisible by 8. So if the last 3 digits are divisible by 8, doesn't matter how many digits come before it, it will all be divisible by 8. So this one, 920 divided by 8 is 115. 9, the sum of the digits is divisible by 9, so it's similar to the divisibility by 3. So for example, 5,868, if we add all those numbers together, you get 27, and we should know that 27 is divisible by 9 because the answer is 3. And 10, similar with the 5 divisibility, we know that anything that would end with a 0 is divisible by 10. Okay, so these are some neat little tricks that can help you when you're looking at divisibility to kind of be able to gauge, am I going to have a remainder or am I going to have an even quotient? Okay, so The first question is asking you to do this. It gives you the numbers 10, 9, 3, 5, 4, and 8, and it's giving you a whole bunch of numbers in a chart. So I've pulled out 4 of them, and they want to know which numbers these can be divisible by. So if we look at 2,710, it ends with that 0. And so if we look at our chart, we can know without even doing anything that it can be divisible by 5 because it ends in a 0. It also can be divisible by 10 because it ends in a 0. Okay? It's not... we would have to do some more work to look at it to see if it's divisible by something like 2, which is not on our list. We could look at it to see if it's divisible by 3 by looking to see if the sum of the digits. So if we take 2, 7, and 1 and we add them together, we get, and 0, don't forget 0. We add them all together, that gives us 10. That is not divisible by 3, so it can't go in the 3 column, so I'll erase that one. We look at the 9. It's the sum of the digits. Is it divisible by 9? Well, we found out 10. 10 is not divisible by 9, so it can't go there. 4, if the last 2 digits are divisible by 4, well, 10 cannot be divided by 4. Oops, forgot I had the eraser on there. And finally, 8. The last 3 digits are divisible by 8. And so we'd have to look into that one, but I'll let you guys figure that one out for yourself. But as you can see, a number can go into multiple columns. So let's look at 60. Again, we can put that beside the 10 because it ends in a 0. And we can put that in the 5 because it ends in a 0. We can see the number even. It would go under 2 if it was available, but it's not. Okay, for 9, is the sum of the digits divisible by 9? 6 plus 0 is 6, not divisible by 9, so it can't go there. 3, are the sum of the digits divisible by 3? Well, 6 plus 0 is 6. We know that 6 can be divided by 3 to get 2, so we could put 60 here. For 4, are the last 2 digits divisible by 4? And we could take a look at that. That's when that handy dandy calculator can help you. If you really want to check, you can really put all these numbers into your calculator, but you can try and make some work. Oh, sorry, not in the wrong spot. So 60 divided by 4 is actually 16, so we can actually put 60 here as well. And 8, the last 3 digits are divisible by 8. Well, there isn't 3 digits, but we can also put 60 divided by 8, and it doesn't give us an even number, it gives us 7.5, so it can't go there. So let's just clear this up. So we've looked at these 2. So now let's look at 2,823. Can it go under 10? No, it doesn't end with a 0, and it can't go under 5 because it doesn't end in a 5 or a 0, so those ones are not possible. So for 9, are the sum of the digits divisible by 9? So let's look at it. 2, 8 is 10, plus 2 and 3, oops, gives us 15. 15 is not divisible by 9. However, if we look at 3, the sum, is that divisible by 3? Yep. 15 divided by 3 is 5. So we can take 2,823 and we can put it here. Okay, we know it doesn't go into 5. And 4 are the last 2 digits divisible by 4. So is 23 divided by 4 an even answer? No, it's not, so it can't go there. And finally, are the last 3 numbers divisible by 8? And we can see that we can do it right here, but 23 is not divisible by 8, so it can't go there. Okay, and the last one that we're going to look at today is 142. Okay, it's not going to go in 10, and it's not going to go in 5 because that last digit's not a 0 or a 5. We can look at the sum because that'll tell us for 1 and 3 and 9. So 1, 4, and 2, we add those together. That gives us 7. That's not divisible by 9. It's not divisible by 3, so we can't put them there. Okay, so then we've got to look at 4. Are those last 2 digits divisible by 4? And they're not, okay, because we should know that 40 divided by 4 is 10, so there's nothing we can do with that 2. And so then the last one are all those 3 digits divided by 8. Well, that doesn't really help us at all, really, because we just need to look at it. And ironically, 142 does not belong anywhere on that chart. So we would leave that one off. Okay, and so there are several other numbers for you to look at. You can either use the divisibility rules and see if that's faster. If you're finding the divisibility rules aren't helping you, grab that calculator, type in that question and see if it gives you an even answer, no remainders, no decimals. And if it is, then you can record it under one of those. Hopefully this helps you. It gives you a different way of looking at division. If you need help throughout your math homework this week, you can contact me through Google Classroom, or you can contact me at p0078359@pdsb.net. How did I write .com? Sorry guys. .net.